And your first chapter is related to the circular motion, right? So that is motion in circle. Okay, just let me know during the class if you find know already about that concept. So we will just quickly go through that concept and we will try to cover that topic that is the new one and that you doesn't know about any idea about that topic. Okay, so we will consider that topic in detail. Otherwise, if you already know about some concept, so we just quickly go through that concept, right?
Okay.
Okay, so basically starting from motion in a circle. So the first of all, in mathematics, you already maybe sometime done about this length of arc and the radius that is shown in the diagram over here. So initially we have to discuss about some circular motion, because in IGCSE level we studied that when body moves in a circular path with constant speed, so that movement or that motion is known as uniform circular motion, right?
Yes.
So, but we know that in circle we have to measure the degrees or radians, right? Because normally we
Yes.
measure degrees because that is clearly mentioned in the diagram, but we need to convert them into radians, right? Because while using in calculation, we usually convert into radians, right? Because for degrees, we need to write some trigonometric identity like sine theta, cos theta, tan theta. But if we want to just calculate the single values, so we use to convert them into radians, right?
Yes.
So first of all, the basic concept is related to angular displacement, that is theta. So we need to know about the angular displacement, and for the angular displacement, we can say that, because they already ask about always ask about 1 mark for the definition of any concept, that is the change in angle in radians of a body as it rotates around a circle. So this is the concept of angular displacement, very much simple, because from the diagram we can observe that where is actually the theta is and what is the concept of theta. So we are talking about this theta, and this is now angular displacement because we are having uh, angular distance or angular anything that we want to write. There will be some specific angle. So we can write delta theta as, so angular displacement will be equal to distance traveled around the circle, right? Divided by the radius of the circle, right? Now you can easily mark the values because S is given over here. That is the arc of the circle or the arc length of the circle, and radius is clearly mentioned over here. That will remains constant throughout the motion, right? Any confusion?
No.
So this is the very first equation and the very first concept. And I hope somewhere you also use this equation in your mathematical concept, maybe because that is also related, like to find the arc length of a circle, S equals to r theta, right? Okay, the next thing is that we need to discuss related to this angular displacement is that when we are using values in radians, because in this chapter we have to discuss or we have to find out the value in radians. We are not going to write cos theta, tan theta, sin theta with the angles. So radians are commonly we write in the terms of pi. If you observe, like 2 pi r, 3 by 4 pi, like this. So we commonly write radians in terms of pi. So let's suppose if we consider the value of pi, and if we consider complete one circle, right? Complete circle, how many degrees are there? 360.
360.
Yes, but that is degree. We need to convert into radian, right? So to convert into radian, what we need to do, we need to consider circumference of the circle, right? So the circumference of the circle will be equal to, any idea that how much will be the circumference of a circle?
180.
Okay, that is 2 pi r. So that will be equal to 2 pi r divided by r. So that will be finally equal to 2 pi. So let's suppose if someone asks you about the radians or to write the value for one complete circle in radian, so that will be equal to 2 pi. Okay, because we know that one complete gives you the value 360, and 360 divided by 2 pi will be equal to 180 divided by pi, like this. So let's suppose if we just consider a numerical value, if we consider 360 degree is equals to 2 pi radians. So we need to find out that 1 radian, how much 1 radian is equals to. So we can just simply find out 360 divided by 2 pi. So that will be equal to 180 divided by pi, right? And by dividing the value, you will get the approximate answer 57.30. Okay, clear? Any confusion?
No.
Okay. And let's suppose if you need to convert degrees into radian, so we need to use a formula like that. Let's suppose this is the given value of theta. It may be anything 30, 40, 90, 65, or anything. You just need to multiply it by pi by 80. So you will get your answer in radians. Okay.
Okay.
And there are some famous values like 360 is equals to 2 pi. And if we consider 270, so 270 will be equal to 3 pi by 2. You can just simply calculate by using the above equation. And it will be equal to only pi, because that is already half. And 90 will be equal to pi by 2. Okay. So this is the concept. Any confusion?
No.
Because this is the basic, and we need to study these small things, because at any point, let's suppose if we need to find out or need to convert anything, so we have to learn that concept again. So that's why it is better to understand in the first chapter. Okay, last time in IGCSE, we only talk about the concept of the angular speed, but we never discuss about how to drive that, what is the symbol of that angular speed, like that. So this time we have to discuss about angular speed also. because we know that when displacement is angular, so your speed will also angular, right?
Yes.
So there is a diagram that is showing you two important things. The first one is that one is the angular velocity, right? This one is the angular velocity, which is completely around the circle, or like in a circular path, right? But there is an other
Yes.
component of velocity that is the linear one, this one, right? And what is the concept of linear velocity? If you remember from your previous content, that in circular motion we discussed that if, let's suppose, if your string got break, let's suppose if we consider example of a stone connected with the string, and you are just moving that stone in a circular path, and suddenly that string just slipped from your hand, or that string just break uh, from any point between the thread, so in which direction that object will move? It will always move in a straight line that is always tangent to the circle, right?
Okay.
In this direction. It will always tangent to the circle, right? So that's why they use
Yes.
the concept of linear speed. So at any point, let's suppose if your thread got broken over here, now you can see there is a gap, right? So stone will not move in circular path anymore, right? Because we know the concept of resultant forces, so there are different or we can say that there are two components of velocity. One is the angular, second one is the linear. So linear velocity is actually at each and every point on the circle, and you can identify that component with the help of this concept, that if you just release that thread from your hand, so body will always move in a circular path, oh sorry, in a straight path, and that straight path is always tangent to the circle. You can identify that point by making tangent line on the circle. Let's suppose if we consider point over here, so you can make tangent again to find out the direction, right? So that is very easy. Just follow the direction of rotation and just mark a tangent line to the circle to find out the linear speed. Now we have two speeds. One is angular and second one is the linear, right? Because we studied in the concept of circular motion that speed of the body remains constant, but still there is a concept of centripetal acceleration. And why centripetal acceleration produced over there? Did you remember that?
Um,
Because of
because of the
because
acceleration.
actually centripetal acceleration produced due to change in velocity, right? But we discussed that speed is constant in circular motion, so acceleration will produce because of change in direction, right? Because at every point you can see that like this, the direction of velocity is changing at every point, right?
Yes.
So due to this change in direction, there is a concept of centripetal acceleration, right? I will also write that point in the column of centripetal acceleration, that why centripetal acceleration will produce, because that is also an important point, right?
Yes.
Any confusion?
No.
Okay. So again, we need to write about the angular speed. So the angular speed is equals to the rate of change of, or the rate of change in angular displacement with respect to time, because we already just write the word rate, so we don't need to write time again and again. because in scientific term we know that a rate word explains that quantity is going to be divided with the concept of time. Okay. And one more thing, if they ask that angular speed is a scalar or vector, so angular speed is a scalar quantity, right? You know there is a difference between speed and velocity. Speed is a scalar quantity, velocity is a vector quantity. So angular speed will be scalar one, right? And what will be the SI unit? Any idea?
Um, SI unit,
Uh,
meters per second.
okay, so that is for the linear speed, right? Now we are talking about the angular. So initially we discussed that we need to measure angle in radians, right?
Yes.
So your SI unit will be radians per second, right?
Second.
Yes, because now we are talking about the angle, not about the straight path, straight distance, right? So for straight linear speed, we know that distance will be equal to meter per second. But for the angular one, we know that there is now angle that is in radian. So your SI unit will be equal to radians per second. Clear?
Yes.
So this is the concept of, or the basic concept of the angular speed. And one more thing that I was talking about, that is for the direction. So basically, when an object is in uniform circular motion, is in uniform circular motion, so initially we only talk about angular speed, but if we talk about velocity, so you know that velocity is a vector quantity, so direction will continuously changing. So velocity constantly changes direction, and you already observe that how the direction of velocity changes, always tangent to the circle, right? So the direction is continuously changing, but speed remains same. Clear? Any confusion?
No.
So that
It's
is
clear.
the yes, that is the point I was talking about, that why centripetal acceleration will produce. So this green point actually gives you the concept that why acceleration is produced when speed is constant, right? So the second important thing is to find out the formula for angular speed, just like the angular displacement we discussed, we need to find out the formula for angular speed also. So we know that first of all we need to write the symbol. So omega, basically this is a symbol of omega, uh, like it is like small w, but it is like the curve one, so that is omega actually. I will write the name of the symbol. So the name of this symbol is omega, and this symbol is actually we use for the angular speed. So if we want to find out the formula for angular speed, so we know that according to the definition, angular speed is equals to rate of change in angular displacement. So delta theta over delta t. Okay. So delta theta over delta t is the formula derived from the basic definition of angular speed, right?
Yes.
Okay. So this is the basic concept that we drive, and we know that we are talking about one complete circle again, right? So we already discussed that one complete circle is equals to 2 pi radian, right?
Yes.
And time to complete one circle, or you know that time to complete one vibration is known as time period, right? Remember that.
Yes.
So we are going to use capital T, that is for time period, capital T. I will also explain this point so there will be no confusion. This capital T is to complete vibration. Okay. So capital T is time to complete one vibration, simple words, a time period, right? And you know that from the relation that we already studied, that over T is equals to which quantity? If you remember from the wave section, that is
Frequency.
equal to frequency. Yes, very good. So that will be equals to frequency. So in simple words, we can say that omega will be equals to 2 pi f, right?
Yes.
Because we replace 1 over T with f. So this is first equation for angular speed, right? And one equation that we discuss in the angular displacement, that is delta theta is equals to delta s over r. And the second equation, but that is first one for the angular speed, that is omega is equals to 2 pi over to f. Okay, one more thing. Now we need to compare a linear velocity with the angular speed, right? Now the linear speed and the angular speed, we need to find out the relation between them, right? So what we need to do, we know that the linear speed and the angular speed both are like the same, but only there is a difference of the linear distance and the angular displacement, right?
Yes.
So we can say that omega can also be written as delta theta over t is equals to over r, because we know that v is the linear component of speed, right? This one, and r is the radius. So if we divide v over r, so that will also give you the value of angular speed, right? Because that gives you the same concept, that is also making the circular path, right? So v is equals to, oh sorry, omega is equals to delta theta over t, or you can also write omega as v over r, or in simple words we can say that your final equation, that will be equal to v is equals to r omega. Clear?
Um, Sir, can you explain from V is equal to V over R? From
Okay.
that point,
Okay.
I cannot understand.
Okay. Basically, if you want to find out the value of omega, right? When object is moving in a circular path with constant speed, right? So initially we discussed that the angle subtended over here with respect to time, right? And you know that the value of time
Yes.
is not given in the diagram, because that we need to measure individually, right? That cannot be driven through or from the circular form, right? But if we want to consider the omega or the angular speed, so when object is traveling at constant speed in a circular path with constant radius, so we can also find out the angular speed with the reference of linear speed divided by the radius. Why? Because radius is constant, right?
Yes.
This value will remain same throughout the motion. And the linear speed is also constant throughout the motion, right? Because we write in the definition that when object is in a uniform circular motion, velocity direction is continuously changing, but speed remains the same.
Okay.
Okay. So that's why we use the concept that with the help of a circle, we can say that in angular speed is also equals to v over r, right? because if we just split into a single form, that velocity itself is equals to what? Distance over time, right?
Yes.
So if you just write a d over t in the place of v, so when we shuffle the values, so t and t will automatically got cancel out, right? So that's why in
Yes.
short we can say that omega will be equal to v over r, right? And v is equals to r omega, because v and r are given in your diagram, and you can use the concept of right angle triangle, and you can easily find out the concept of angular speed. Okay, so that is the
Okay.
concept. And from this equation you can easily identify that the greater the angle, the greater will be angular speed, right? Because angular speed and theta are both directly proportional, and the time is inversely one, right?
Yes.
So it means that if you increase the radius, so that will decrease your angular speed. Okay,
Okay.
that we already discussed in the previous IGCSE section related to centripetal force and centripetal acceleration, right?
Yes.
Any confusion?
No.
Okay. Okay. Basically, we try to end up this chapter very quickly, because that is the shortest one and more basic, like related to the IGCSE, right? But when we are doing the topical, so that will also give you the revision of this topic, right?
Okay.
And you will also get the recorded file, so don't worry about any concept. Okay. So that is the thing we were talking about in the previous section, that why acceleration will produce in your motion when your speed is constant, right? So if you remember in IGCSE level, we also used to discuss that to find out the direction of resultant force, right? And if you remember those questions with the circular motion, your direction will always towards the center of the circle, right?
Yes.
Okay, so we know that in centripetal acceleration, uh, or if we talk about the direction of the resultant force, you can see that this F gives you the concept of the centripetal force, and it is mentioned that centripetal force and acceleration are in the same direction, right? Because both follows Newton's second law, because acceleration is also directly proportional to the force. So if you increase the force, acceleration will also increase. So acceleration will also follow the same direction with the direction of force, because both are vector quantities, right?
Yes.
And this is the thing that we were talking previously, that velocity is always tangent to the circle, right? So that is already written over here. And the next uh, the next thing we need to discuss is related to centripetal acceleration. So in this concept we are going to talk about centripetal acceleration.